Welcome to the fifth lecture on electrostatic field and charge. Electrical field and charge. Fifth lecture for class 12 physics students. Today's topic is torque on electric dipole, and this is for HSC, CBSE and ISC students. Class 12 physics, electrostatics, torque on an electric dipole. Or electric dipole torque. Class 12 physics, electric field, electric charge, electrostatics. So the title is torque on electric dipole in a uniform field. You look at the figure. Here in the figure, a dipole is shown. It is inclined, plus q, minus q charges. You look at the figure, plus q, minus q charges. Their separation is also given as A. It is in a field of intensity E, inclined at an angle theta to the field direction. A triangle is constructed. A triangle, right angle triangle is constructed. Theta is shown at two places. And from that figure, we can also find sin theta. Sin theta is opposite side by hypotenuse. Opposite side by hypotenuse. Opposite side is we get as A sin theta. A sin theta by A is sin theta. So the perpendicular distance between the line of action of the forces. So consider dipole. It is placed in the field plus QE. QE is the force acting on plus Q charge. Minus Q is the force acting on minus charge. These two forces are opposite because the charges are opposite. Since the line of action of the forces, the line of action of the forces are different, they will constitute a couple. It has a torque, and a torque is measured as under. So here there is a small explanation is given. We can understand it. Consider an electric dipole consisting of charges minus q and plus q and length A placed in a uniform electric field of strength E. The axis of the dipole makes an angle theta with the direction of E. The magnitude of force acting on the charge plus q is QE and is in the direction of E. Similarly, the force of the charge minus q is minus QE and is opposite to E. So the net translatory force acting on the dipole is QE plus minus QE is 0. But these two equal and unlike forces constitute a couple. The moment of the couple or torque acting on the dipole in magnitude is given by. അപ്പോൾ ഡൈപോൾ വെച്ച് കഴിഞ്ഞാൽ യു ലുക്ക് അറ്റ് ദ ഫിഗർ, ഡൈപോൾ വെച്ച് കഴിഞ്ഞാൽ ഓരോ പോളിലും QE ഫോഴ്സ് ഓപ്പോസിറ്റായി പ്രവർത്തിക്കും. അവ ഒരേ ലൈനിലല്ല, ഡിഫറെൻറ്റ് ലൈൻസ് ഓഫ് ആക്ഷനിലാണ്. അതുകൊണ്ട് അവ ഒരു ടോർക്ക് ഉണ്ടാക്കും, അല്ലെങ്കിൽ മൊമെന്റ് ഓഫ് കപ്പിൾ ഉണ്ടാക്കും. അത് നമ്മൾ കാണുന്ന രീതിയാണ്. ഈ ടോർക്കിനെ നമ്മൾ ടോ എന്ന് മാർക്ക് ചെയ്യും. അത് അളക്കുന്നത് വൺ ഓഫ് ദി ഫോഴ്സസ് ഇൻ ദി പെർപെൻഡിക്കുലർ ഡിസ്റ്റൻസ് ബിറ്റ്വീൻ ദം. That is tau is equal to q into perpendicular distance. And perpendicular distance we have seen the figure. It is perpendicular distance we have seen the figure as A sin theta. So that we put here. On putting here, we get tau is equal to QE into A sin theta. But QE is equal to P, dipole moment. So torque is equal to PE sin theta. This is the torque on an electric dipole placed in a field of intensity E inclined at an angle theta to the field direction. P dipole moment ഉള്ള ഒരു ഡൈപോൾ ഈ ഇൻറ്റൻസിറ്റിയുള്ള യൂണിഫോം ഫീൽഡിൽ തീറ്റ ഇൻക്ലൈൻഡ് ആക്കി വെച്ചാൽ അതിൻ്റെ പുറത്തുള്ള ടോർക്ക് പി സൈൻ തീറ്റയാണ്. And this relation we also write in vector form. In vector form we write as torque is P cross E. P is the dipole moment vector and E is electric field vector. You know the definition of cross product. Modulus A, modulus B, sin theta into unit vector. So we can write it as P cross E. P and E are vectors. The direction of tau is perpendicular to both P and E as given by the right-handed corkscrew rule. Clearly, the torque is maximum when theta is 90. You know, sin 90 is 1, it is the maximum value. Theta is maximum, theta, torque is maximum when theta is 90. That is when the dipole is perpendicular to the, not a magnetic, electric field. We are discussing electric field by mistake. Magnetic is written there. Electric field and the maximum torque is given by tau max is P into sin 90, that is PE. Our minimum torque is 0 when theta is 0. So the torque on a dipole placed in a uniform electric field, remember electric field inclined at an angle theta to the field direction is tau is P sin theta, is maximum value is tau max equal to PE. And a question relating this may be like this. A long answer question. Derive an expression for the torque acting on an electric dipole placed in a uniform electric field. ഒരു യൂണിഫോം ഇലക്ട്രിക് ഫീൽഡിലുള്ള ഡൈപോളിൽ പ്രവർത്തിക്കുന്ന ടോർക്ക് കണ്ടുപിടിക്കുക. ടോർക്ക്, ഫോഴ്സിന് ഡിസ്റ്റൻസ്. And this is a problem based on torque. An electric dipole of length 10 cm placed in at an angle of 30 degree with uniform electric field of intensity 3 into 10 raised to 3 Newton Coulomb raised to minus 1 experiences a torque of magnitude 5 into 10 raised to minus 5 Newton meter. Calculate the dipole moment of the dipole and the magnitude of electric charge. അപ്പോൾ ഒരു ഡൈപോൾ യൂണിഫോം ഫീൽഡ് വെക്കുമ്പോൾ അതിൽ പ്രവർത്തിക്കുന്ന ടോർക്കിൻ്റെ വാല്യൂ നമുക്ക് തന്നിരിക്കുകയാണ്. നമുക്ക് കണ്ടുപിടിക്കുന്ന ഡൈപോൾ മൊമെൻ്റ് ആണ്. സോ ഈസ് ഗിവൺ 3 into 10 raised to 5 Newton Coulomb raised to minus 1. Theta is also given in the question 30 degree. And distance, torque is 3 into 10 raised to minus 5 Newton meter. And we know the relation tau is P sin theta. Therefore, P is equal to tau by E sin theta. We write the value of tau 5 into 10 raised to minus 5 by 3 into 10 raised to 5 into sin 30. And you know sin 30 is 1 by 2.5. We put the value tau is equal to 5 into 10 raised to minus 5 by 3 into 10 raised to 5 into 0.5. On cancellation, you will hear is 3 into 10 raised to minus 5. Minus is the field is minus. You look here, what is the value? No, it is plus 5. The field is 3 into 10 is plus 5. On calculation, we get 1 by 3 into 10 raised to minus 9. Minus 9, that is dipole moment. Unit is Coulomb meter. Then magnitude of charge Q. You know P is equal to QA, dipole moment. So Q is equal to P by A. 1 by 3 into 10 raised to minus 9 by the length of dipole. The length of dipole is given as, you look at this, 10 centimeter. 10 centimeter is 0.1 meter. So 1 by 3 into 10 raised to minus 9 by 0.1, it is equal to 1 by 3 into 10 raised to minus it, because 0.1 is 10 raised to minus 1. So 10 raised to minus 9, 10 raised by 10 raised to minus 1 is 10 raised to minus 8. So magnitude of charge Q is equal to 1 by 3 into 10 raised to minus 8 Coulomb. അതാണ് പ്രോബ്ലം. അപ്പോൾ ടോർക്ക് ഉപയോഗിച്ച് നമ്മൾ മൊമെൻ്റ് കണ്ടുപിടിക്കുന്ന പ്രോബ്ലം. ആ മൊമെൻ്റ് ഡൈപോൾ മൊമെൻ്റ് കണ്ടതിന് ശേഷം അതിൽ നിന്ന് ചാർജ് കണ്ടുപിടിക്കാം. അതിൽ പി എസ് ക്യു എ എന്നുള്ള ഡൈപോൾ മൊമെൻ്റ് ഡെഫിനിഷനാണ് ഉപയോഗിച്ചത്. And that is all with our 5th lecture on electrostatics. Thank you very much.